Hello students, in the previous video we studied a few numericals regarding the electricity chapter, and I gave you a particular numerical in homework and we will solve that numerical today. Okay, so the question was, a copper wire has diameter 0.5 millimeters and a resistivity of 1.6 into 10 raised to minus 8 ohm meters. What will be the length of the wire if it was to make 10 ohm resistance? Okay, so the question is, if we want to make the resistance to be 10 ohms, then what will be the length of the wire? So obviously we know the formula for finding the resistance, that is R is equal to rho into L upon A, where rho is resistivity which has been given to you and length is what you need to find if the resistance is 10 ohms. So we have been given the resistance, we have the resistivity, but we don't have the area. And we know that a wire is actually a cylindrical structure which is like this. A cylindrical structure has circular cross section area, so the area of cross section is circular. So whichever part if you cut it, okay, then you will find out that its cross section area is circular form, and we know the area of cross section or the area of a circle is pi r square. But in order to use radius, we have been given diameter. So first thing is we have to convert diameter into radius. So obviously radius is half of the diameter. So I have given all the formulas over here. So in order to use the area, which we need to use in this formula, we first need to convert this radius from diameter. So first of all, we have been given diameter as 0.5 millimeters. So that is d by 2 is equal to 0.5 by 2 millimeters. Okay. Now obviously this is in millimeters and the resistivity is in ohm meters. So we will have to convert this into meters, and obviously millimeters to meters, we are going from smaller value to a bigger value, a bigger unit. Then you have to divide it by 1000. Just like when you go from meters to kilometers, it is dividing by 1000. If you go from kilometers to meters, it is multiplying by 1000, and from meters to millimeters, again multiplying by 1000. But if you are going from millimeters to meters, then it is dividing by 1000. So what you get over here is 0.5 by 2 into 1000. Okay, now it has become meters. Understood? Okay, now that we have the radius, we can apply the formula for area. Area is equal to pi r square, that is you can use the value of pi as 3.14 into radius square, so 0.5 by 2 into 1000 whole square. This is what you are supposed to do. Understood? We have the radius, we have the value of pi, and obviously we have the value of area. Now all you need to do is substitute all these values over here in this value. You're observing that I am not solving this part over here, and there's a reason for that. This is quite a bigger number, and what we have over here, resistivity, is also quite a bigger number, that is 10 raised to minus 8 ohm meters. So you will see in a few minutes what I'm trying to say over here. Okay, so now we move on to the next part, that is finding the length. We have been given resistance R is equal to rho into L upon A, where resistance is 10, okay, is equal to rho, that is 1.6 into 10 raised to minus 8, into length that you need to find, upon area, that is 3.14 into 0.5 upon 2 into 1000 whole square. Getting all the students? You can pause the video and see that is R is equal to rho into L upon A. This is whole area that we just found out over here. Okay, solving this further, what you get is 10 is equal to 1.6 into 10 raised to minus 8 into L upon 3.14 into 5 5s 25 and 2 decimal points, so 0.25 upon 2 2s is 4. Now obviously we know that if we square 1000 into 1000, it becomes 6 zeros. So I can write 10 to the power 6, that is multiplying 10 into 6 times, so I can get 6 zeros. This is what we studied in powers and exponent in standard 8th and 9th. Quite simple actually. This is 1000, so I can write it as 10 raised to power 3, and if I am squaring that, so 10 raised to 3 into 10 raised to 3 becomes 10 raised to 3 plus 3, so you get 10 raised to power 6. Simple mathematics. Okay. If anyone still having doubt, I will do it over here. It is like this: 1000 into 1000, it becomes 10 raised to power 3 into 10 raised to power 3, which is, if the bases are same, then the powers add up. This is 10 raised to 3 plus 3, so it becomes 10 raised to power 6. I hope it is clear to you, students. Now, because this is in denominator and this number is in the denominator of the denominator, so it goes up in the numerator, becomes multiplication. So it becomes 10 is equal to 1.6 into 10 raised to minus 8 into 4 into 10 raised to power 6 into L upon 3.14 into 0.25. Getting, students? So I took all this value over here in the numerator. Okay. Now you have to solve this further, but over here you see why I didn't do this, because now once again we have 10 raised to minus 8 and 10 raised to power 6. Once again they are also in multiplication. All these values are in multiplication, so I can change the places. It doesn't matter, they are going to multiply anyway. So it becomes 1.6 into 4 into 10 raised to minus 8 into 10 raised to 6 into L upon 3.14 into 0.25. Okay, we will solve in the next page. So what happens is 10 is equal to 1.6 into 4 into 10 raised to power minus 8 into 10 raised to 6 into L upon 3.14 into 0.25. Now because the bases are same, the powers will add, so I am doing it over here. So just for your knowledge purpose, 10 raised to minus 8 plus 10 raised to power 6, the powers get added. Minus 8 plus 6 becomes 2 and the sign of the bigger number, so what you get is 10 raised to minus 2. So I am writing directly over here, that is 10 is equal to 1.6 into 4 into 10 raised to power minus 2 into L upon 3.14 into 0.25. Now at this point, all you can do is directly multiply this stuff, or you can simplify them, but because they are already in quite smaller numbers, it is better to just multiply them. So multiplying 4 6 24, 4 ones is 4 plus 2 6, so what you get over here is 6.4. 6.4 into 10 raised to minus 2 into L upon, you can also multiply this as well, simple multiplication, or you can leave it like this, 3.14 into 0.25. Now in order to leave it like this, you can also further solve it by, because these two are even numbers, you can use 2 3s, 2 2s, point, 2 1s, 1 is remaining, 2 5s 10, 2 7s 14. So what you get, next number 10 is equal to 3.2 into 10 raised to minus 2 into L upon 1.57 into 0.25. Okay. Okay, so now because we want the value of L, that is the length of the wire, what we need to do is we need to separate this. We need to find the value of L. So cross multiply all of the other values on the other side of the equal to sign. So for that, take this value and cross multiply it with 10. So what you get is 10 into 1.57 into 0.25, and this 3.2 into 10 raised to minus 2 goes in the denominator like this, so it becomes 3.2 to 10 raised to minus 2 is equal to L. Okay, I hope you are getting, students. Now all you can do is multiply these values, so I will make it simpler for you. It becomes 15.7 into 0.25 upon 3.2 into 10 raised to minus 2. Now obviously this is equal to on the right hand side, so it doesn't matter because we are finding the value of L. So I can write L is equal to 15.7 into 0.25 upon 3.2 into 10 raised to minus 2. Now simply multiply this value and then you can divide it later. So solving this 15.7 to 0.25, you get 3.925 upon 3.2 into 10 raised to minus 2. It becomes 10 raised to minus 2 like this. Okay, you can solve it further by directly using the table of 32, or you can simplify it even more by moving the decimal points on the right hand side. So if I want to move the decimal place on the right hand side, then I have to multiply it by 10. So if I am multiplying it by 10 in the bottom, I have to multiply it by the 10 on the top hand side as well. So this becomes 39.25 upon 32 into 10 raised to minus 2. This remains as it is. So now I have 39.25 upon 32 instead of complicated decimal points. Now you can directly use the table of 32, or you can use by simple table of 2, simplify it further, but what you will get is 1.226 upon 10 raised to minus 2. When you solve it, the number is obviously longer than this, but you have to take approximate values, and I have taken 3 decimal places. So 1.226. Now because there is 2 raised to minus 2 in the denominator, I take it in the numerator, it becomes 1.226 into 10 raised to plus 2. So because it was in denominator and took it in numerator, so the minus sign of the power changes to plus sign. So if it is in numerator and take it in denominator, again the power changes. So minus 2 changes to plus 2, and multiplying by 2, I have to move 2 decimal places. So finally it becomes 122.6 meters, because this is the length of the wire. So if we are taking a copper wire whose resistivity is 1.6 into 10 raised to minus 8 ohm meters, okay, then we find out that its length is 122.6 meters if the resistance has to be 10 ohms. Understood? So if I want to take the copper wire whose resistance is 10 ohms, then its length will be 122.6 meters. Okay, I hope it is clear, students. Now we move on to the second part of the question. So for the resistance, what will happen to the resistance if the diameter is doubled? So let me solve this question for you in a different matter. We don't need to go through all of these numbers. We will use this at the very end. So the question is, resistance R is equal to rho into L upon A, right? Where A can be written as L into pi R square, right? Or I can add rho into L upon pi d by 2 whole square. Correct? So because resistance, we have been given diameter over, we are not given the resistance, so I am writing it in terms of diameter. So diameter is by 2. The question is, what happens if the diameter is doubled? So I am multiplying it by 2. It is being doubled. So instead of using the same diameter, now I am using the 2 times of the diameter by 2 whole square. So simply what I am doing is, I am using the 2 over here, which is to be doubled. When I solve this, what I get is rho into L upon, writing this d by 2 as R, I can write 2R pi into 2R whole square. Correct or not? Because this d by 2 is R, so I am writing it as R. Now removing the square sign, it becomes rho into L upon pi 4R square. Taking this 4 on the outside, I get 1 by 4 into rho into L upon pi R square. And what is the value of pi R square? This pi R square is our original resistance. So this is our second resistance, that is resistance R dash. This part is the for the second resistance. This area, whatever I have solved over here with the second resistance, because I am using the wire with double diameter. So I have changed the diameter, and that is what I am using over here. So 2 into d by 2 whole square. D by 2 is r, so it becomes r, and 2 becomes 4, and r becomes r square. Taking this 1 by 4 on the outside, I get 1 by 4 into rho into L upon pi r square. Now rho into L upon pi r square is what? This is our total resistance R, that is rho into L upon pi r square. This is our total resistance R. So I am writing R dash is equal to 1 by 4 into our original resistance R. So what happens to the value? If I increase the diameter by 2 times, then the total resistance becomes 1 by 4, or I can write R by 4, or the total resistance decreases, because we know that the cross section area, this is the diameter of the wire before, and this is the diameter of the newer wire. It is twice the size. So when the area is more, resistance is less. This is what we have already studied. So the newer resistance R dash is 4 times less than that of the original resistance. So what I have to write, total resistance was 10 by 4, so it becomes 4 2's 8 and 2 is remaining, so 4 5, so it becomes 2.5 ohms. So the newer resistance R dash is 2.5 ohms. It becomes 4 times less. You can pause the video, students, and go through it once again, and if you have any questions, give it in the comments and I will try to explain my best, and then you can remember as well, and we can solve it in the class as well when we meet after the lockdown. Okay students, take care. In the next video we'll start with the newer chapter. Okay.